something just blinked at us from the darkness of space. 4.24 light-years away, a strange light appeared on a planet scientists thought was dead. The James Webb Space Telescope has captured the clearest image of Proxima B. And what it revealed, it's not just shocking. It may be the first sign we're not alone in the universe. Just beyond the edge of our solar system, orbiting the nearest star to the Sun, lies a world cloaked in darkness and uncertainty. Its name is Proxima B, a planet discovered in 2016 that quickly became one of the most intriguing mysteries in modern astronomy. Roughly 1.17 times the mass of Earth and located inside its star's so-called habitable zone, Proxima B should be a promising candidate for life. But there's a problem. Its host star, Proxima Centauri, is unstable. It erupts with deadly flares that could strip away any atmosphere and turn the surface into a radioactive wasteland. For years, scientists debated whether this rocky world was a burned-out husk or something more. Now, the James Webb Space Telescope has ended the speculation and started something much bigger. It has captured an image unlike anything we've seen before. Something strange, something impossible to ignore. This is the beginning of a new chapter in space exploration and possibly a new understanding of our place in the cosmos. Proxima B wasn't discovered through a photograph, but through a wobble. Back in 2016, astronomers at the European Southern Observatory noticed a subtle movement in the light of Proxima Centauri, a red dwarf star located just 4.24 light-years from Earth. This wobble wasn't random, it was gravitational. Something small but heavy was tugging on the star. That something became Proxima B. From the beginning, the planet was full of contradictions. It orbits within the habitable zone, the region around a star where temperatures could allow for liquid water. That should be good news. But the orbit is extremely close to its star, just 11.2 Earth days to complete a full revolution. And its star, a red dwarf, cool by stellar standards but highly unstable. Proxima Centauri frequently unleashes solar flares so intense they dwarf those of our own Sun, sometimes by 100 times. These flares release streams of ultraviolet and X-ray radiation, which, over time, could strip away any atmosphere on the planet, leaving it airless and lifeless. On Earth, we're protected by a magnetic field and thick atmosphere. But could Proxima B have the same? At the time, we didn't know. And for nearly a decade, the mystery deepened. Was Proxima B a burnt, irradiated rock? Or was there a protective force, a magnetic field, an atmosphere, even clouds that shielded it from stellar wrath? The planet is roughly 1.17 times the mass of Earth, rocky like our own, and may even have gravity similar to ours. But its biggest challenge isn't the surface, it's the star above it. And then came something no one expected. The first signs that Proxima B might be surviving. Not just surviving, thriving. In 2021, a new eye opened in the sky. The James Webb Space Telescope, humanity's most advanced instrument ever sent to space, was launched to do what no telescope before it could: see the invisible. While its predecessor, Hubble, gave us stunning images of galaxies and nebulae, Webb sees in infrared, the language of heat. It can peer through dust, see into the past, and most importantly, detect signs of life. With a 6.5-meter gold-plated mirror made of 18 hexagonal segments, Webb now orbits 1.5 million kilometers from Earth at the second Lagrange point, where it's shielded from the sun's interference and can stare deep into the cosmos undisturbed. In early 2025, it was Proxima B's turn. For the first time in history, Webb locked its sensors on this mysterious exoplanet, and what it returned wasn't just a blurry silhouette, it was something clear, structured, alive with detail. Using its NERCam and MIRI instruments, two infrared cameras working in tandem, Webb captured heat signatures from Proxima B's surface and atmosphere. These instruments don't just take pictures, they dissect light, breaking it into data that reveals chemicals, energy, motion. The result? A direct thermal image of the planet. Spectral readings confirm the presence of carbon dioxide, water vapor, and, most surprisingly, a potential methane anomaly. While none of these alone prove life, together they raise eyebrows. But that wasn't the moment that stunned scientists. It was what they saw on the night side of the planet, the hemisphere permanently facing away from its star, a pattern of faint, organized light, not flickering like volcanoes or glowing in random pulses like heat currents. This light had rhythm, structure, geometry, something that nature rarely does. But technology often does. And just like that, Proxima B transformed from a distant rock to a potential beacon in the dark. At first, the image looked like nothing more than scattered heat data, pixels glowing softly in the cold silence of space. But when scientists enhanced the contrast, mapped the infrared patterns, and filtered out natural radiation noise, something strange emerged on the planet's dark side. A cluster of lights, faint, organized, geometric, not scattered randomly like volcanic eruptions, not following the chaotic path of atmospheric heat transfer. These lights had symmetry, patterns, repetition. Some formed lines, others clusters, but all of them shared one trait: they didn't look natural. And that's when the question hit like a thunderclap across the astrophysics community. Is this artificial light? The idea is staggering, but not impossible. Scientists quickly proposed three competing explanations. 1. Atmospheric circulation. Infrared heat might be carried by powerful wind systems from the planet's day side, glowing briefly on the night side. Plausible, but the light's spatial patterns don't match known atmospheric flows. 2. Volcanic activity. Superheated magma vents or lava flows could explain thermal emissions, but these lights didn't flicker, surge, or pulse the way volcanic hotspots do. They were too consistent. 3. Artificial origin. Light from technology, power grids, cities, industrial zones, beacons. The patterns match no known natural phenomenon, but resemble something we would build. The very idea that intelligent life might exist just over 4 light-years away has reignited debates long considered science fiction. Could we be seeing a civilization that evolved in darkness? One that built structures illuminated by thermal or chemical light? Proxima B's eternal night side creates a strange but stable environment, a place shielded from flares with steady cold and no solar interference. And in that twilight, life could thrive. On Earth, extremophiles survive in pitch-black ocean vents, feeding off heat and minerals. Entire ecosystems exist in complete darkness. Could Proxima B host something similar? Or something far more advanced? What's even more compelling, the spectral data didn't just show heat. It revealed a slight dip in infrared wavelengths associated with reflective materials, possibly metals. Are we seeing thermal reflections bouncing off artificial surfaces, solar panels, structures? For now, we don't know. But one thing is clear, this is not random. Something is happening on the far side of Proxima B. and it's glowing in ways we can't yet explain. If the light is real, then the next question becomes unavoidable. Could there be life on Proxima B? For decades, the answer leaned toward no. The radiation from Proxima Centauri is brutal, blasting its planets with ultraviolet and X-ray flares strong enough to sterilize entire worlds. But then, Webb found something else: traces of water vapor in the atmosphere, hints of carbon dioxide, methane, and even ozone-like molecules, all detected by the telescope's spectrometers. These compounds are commonly associated with planetary processes, but more importantly, on Earth, they're linked to life. And here's where things get really interesting. Proxima B is tidally locked, meaning one side always faces the star, while the other remains in permanent night. But in between, there's a thin band of eternal twilight, a stable zone where temperatures might be just right. Not too hot, not too cold. If life evolved there, it would have had to adapt to extremes: intense radiation on one side, freezing darkness on the other. But Earth has shown us that life always finds a way. We've discovered organisms called extremophiles that survive in boiling acid deep-sea trenches, nuclear reactors, and even outer space. In 2007, the European Space Agency exposed Dinococcus radiodurans, a radiation-resistant bacterium, to space vacuum and UV rays for over a year. It lived. In the coldest regions of Antarctica, we've found microbes living inside ice crystals, metabolizing slowly in near total darkness. So, what if Proxima B has its own extremophiles? Or better yet, what if life there isn't just surviving, but thriving? Perhaps under the surface, beneath rock layers shielding from radiation, oceans of subsurface water provide refuge. Maybe they use geothermal energy instead of sunlight. Maybe their biology is based on methane instead of oxygen. Maybe they've adapted to the darkness so completely that light itself, artificial light, became their tool for survival. These aren't just fantasies, they're scientific possibilities. And if that faint infrared glow is artificial, we might not be asking if life exists there. We might be asking what kind of civilization already calls it home. The moment the image of Proxima B was made public, the world changed. Within hours, headlines flooded global media. James Webb detects artificial light on nearby exoplanet. Scientists speechless after infrared anomalies detected on Proxima B. Have we found alien cities? But it wasn't just the press reacting. The scientific community moved fast. SETI, the search for extraterrestrial intelligence, immediately redirected multiple radio telescopes toward Proxima Centauri, attempting to capture any signal, no matter how faint, that might match the planet's orbital frequency. Meanwhile, the breakthrough initiatives, backed by billionaires like Yuri Milner, proposed accelerating Starshot, a program to send miniature laser-propelled probes toward the Proxima system. These probes, the size of microchips, could reach the star in just over 20 years at 20% the speed of light. At the same time, ESA and NASA began discussing follow-up infrared observation windows, trying to repeat and confirm the light pattern data. But it didn't stop with science. On social media, the discovery went viral. Artists reimagined alien cities glowing in eternal twilight. Writers speculated on first contact scenarios. Filmmakers began rewriting scripts. The cultural imagination was reignited. In classrooms around the world, children asked new questions. Could we live there? Do they know about us? Are they watching? Philosophers debated ethics. Theologians re-examined sacred texts. Politicians even weighed in, some urging caution, others pushing for interstellar exploration. And amidst the noise, one feeling echoed across humanity: wonder. Wonder, mixed with a quiet, thrilling fear, because if we are truly not alone, then everything changes. Our understanding of life, of evolution, of our place in the cosmos. Proxima B is no longer just a dot in the sky. It's a question, a possibility, a mirror reflecting what we might become, or what someone else already is. What if this is just the beginning? The James Webb Telescope may have opened the door, but there are new instruments coming that could walk right through it and show us what's really there. First, the Extremely Large Telescope, or ELT. Currently under construction in Chile's Atacama Desert, the ELT will be the most powerful optical telescope ever built. With a 39.3-meter mirror, nearly the size of a soccer field, it will collect more light than any ground-based telescope in history. This behemoth will use adaptive optics to cancel out atmospheric distortion, and its advanced spectrographs, like Harmony and Metis, will analyze the light from exoplanets like Proxima B with breathtaking precision. It will be able to detect the faintest of signals: methane, oxygen, water vapor, and even unusual heat patterns. It could potentially confirm whether that mysterious light Webb detected is natural or artificial. Then comes NASA's Nancy Grace Roman Space Telescope, launching in 2027. Think of it as James Webb's wide-angle cousin. Its massive field of view will let us survey exoplanetary systems in bulk, watching their behavior over time, capturing rare alignments, and identifying targets for direct imaging. And beyond that, the proposed LUVOIR mission, short for Large UV Optical IR Surveyor, will dwarf even Webb. Designed to detect Earth-like planets around Sun-like stars, LUVOIR could resolve features on planetary surfaces, identify continents, oceans, even weather systems, and perhaps the most ambitious of all, HEX, a future concept mission that includes a star shade, a massive flower-shaped disk that blocks starlight to allow telescopes to see the dim planets around it. With HEX, we may get the first unambiguous image of a living world, the glint of an alien ocean, the shimmer of clouds, or even the structured glow of an engineered skyline. Each of these missions builds on what James Webb has started, and all of them are now pointed, at least in part, at one place: Proxima B. Because the question is no longer if we can look deeper, it's when we'll find what's been hiding there all along. Every image tells a story, but some carry more than pixels. They carry meaning. The first clear image of Proxima B is not just a scientific milestone. It's a mirror, a reflection of our curiosity, our fears, our imagination. For centuries, we've stared into the night sky, wondering if we were alone. Now, for the first time, something might be staring back. The James Webb Telescope captured more than thermal data. It captured hope. It captured possibility. Every tiny light curve, every pixel of heat, every spectral line holds the weight of civilizations past and future. From ancient astronomers mapping stars with nothing but their eyes, to modern scientists decoding the atmosphere of a planet 4 light-years away using light invisible to the human eye. That's the soul of science, its power to unite time, culture, and perspective. Right now, researchers are dissecting the image from Proxima B, looking for patterns, simulating its climate, building models of how life might evolve there. But beyond the data, something deeper lingers. A feeling. A pull. Because if Proxima B does host life, whether microbial, intelligent, or something in between, it means we're part of a much larger story, a cosmic ecosystem, a shared universe. And even if we never find a signal, never hear a voice, the simple fact that we're asking, that we're searching, that we care, that says something profound about who we are. We are explorers, not because the universe demands it, but because something inside us does. And Proxima B? It's not just another world. It's a chapter waiting to be written, not by machines, but by us. What if the glow on Proxima B is not just light, but a message? Not in words, not in language, but in presence. A whisper from a civilization we've never met, a sign that we are not the only thinkers, the only dreamers, the only architects of meaning in this vast and ancient cosmos. What if that glow isn't just heat, but a city? A network of artificial light stretching across a world forever cast in shadow. A civilization adapted to darkness, thriving in ways we can barely imagine. What if their telescopes are pointed toward us, just as ours are toward them? What would they see? A pale blue dot, blinking faintly in the glare of our sun. A world of oceans and music and conflict and art. A species young, but hungry to understand. The discovery on Proxima B, if confirmed, would be more than historic. It would be transformative. It would force us to rethink everything: our origins, our religions, our science, our purpose. It would challenge our fear of the unknown and our tendency to see ourselves as the center of it all. We would no longer be the only ones. And maybe that's what we've always needed. Not proof of aliens, but proof that we're part of something bigger. That in a universe of chaos and cold and emptiness, there is still connection. The James Webb Space Telescope has given us a gift, a silent image from 4 light-years away that speaks volumes. The light on Proxima B might be natural or artificial or something we can't even comprehend yet, but one thing is certain: the search has changed forever. And the night sky will never look the same again. Because now, we don't just look at the stars. We wonder who might be looking back. If what you've just seen sparked something in you, then you need to see what we've discovered next. Trust me, you're not ready for it.